So this video goes over section 5.4 of chapter 5 on oxidation and reduction. So oxidation is the loss of electrons from an atom, and reduction is the gain of electron by an atom. And so to remember these better, there is this acronym OIL-RIG. So OIL refers to oxidation is loss of electrons, and RIG refers to reduction is gain of electrons. So by remembering OIL-RIG, you should remember which one is which. So both processes occur together in a single reaction, and so it's called an oxidation-reduction reaction. And because it's a bit long, very often it's just abbreviated as a redox reaction. And a redox reaction always has two components, one that is oxidized and one that is reduced. And so what happens during a redox reaction is that there is a transfer of electron from an element to another. So let's look at an example. If zinc as a metal is placed in a solution of copper ions, Cu2+, you will see that the copper will become the metal. It will deposit into a copper metal, and the zinc will get corroded and become dissolved into the solution, into the ion zinc 2+. And so, so here, if we look at the zinc only, we see that zinc, we start with the solid metal, and that's the element with, we will say, an oxidation state of 0. It's neutral. And then when it becomes zinc 2+, it's an ion with 2 positive charges, which means that zinc lost 2 electrons to become 2+. The 2 electrons are gone, and so the 2 positive charges are coming from the 2 protons that are not cancelled out anymore. So when zinc loses 2 electrons, it's oxidized. So in this case, that's the species that is oxidized. And whenever you have an oxidation, you have to have a reduction at the same time. They have to happen at the same time. And so the copper 2+ gets reduced because it gains electrons. So it will gain those 2 electrons left by zinc. Will gain 2 electrons, and those 2 electrons will cancel out the 2 positive charges on the copper ion. And then we will get the copper metal. So copper in its elemental state, which we also say it's the oxidation state of 0 when it's the neutral metal. And so because Cu2+ gains 2 electrons to form Cu, we say that Cu2+, the ion, is reduced. So each of these processes can be written as an individual half reaction. So you can split what's going on by writing a half reaction about the oxidation and a half reaction about the reduction. And here we know that the zinc is the species that is oxidized, and so we can show that zinc becomes the zinc 2+ ion when it loses 2 electrons. So we add +2 electrons on the side of the cation to show that zinc, lost those 2 electrons. And also it has to be on that side because when you have an arrow, it has to be balanced, and the same thing on both sides. And here you see you have zinc on both sides, and it's neutral on the left, and it has to be a neutral on the right. And you see that the 2 positive charges from the zinc 2+ cancels the 2 negative charges from the 2 electrons. And so indeed we have a neutrality also on the right. The reduction half reaction is for Cu2+. Cu2+ will gain 2 electrons. So you have to add those 2 electrons on the left side because then they will be grabbed by the copper ion to become the copper metal. Cu as a metal is a solid. And so we see that those two positive charges from the copper will be cancelled by the two negative charges from the two electrons. And that's why copper on the right side is also neutral. So, and these two half reactions, if you add them, you know, you align them according to the arrows. And if you add them, you will retrieve the net reaction that you see above. You will see that you have zinc plus Cu2 plus. The two electrons will be cancelled because you will have two electrons on the left side of the arrow and two electrons on the right side of the arrow. So that's why we don't see them anymore in the net reaction. And we see only what has changed. So the on the right side, you have zinc 2 plus Cu. So some vocabulary that will be necessary for the homework in particular. So a compound that causes another compound to be reduced is called a reducing agent. And in this example, where zinc was oxidized and Cu2 plus was reduced, the reducing agent is zinc, because zinc causes Cu2 plus to gain electrons and become reduced. So that's why zinc is the reducing agent here. Zinc gets oxidized, and by being oxidized, it reduces the other species. So it's the reducing agent. And a compound that causes another compound to be oxidized is called an oxidizing agent. And in the example above, copper 2 plus acts as the oxidizing agent because it causes zinc to lose electrons and become oxidized. So copper here is reduced. Copper 2 plus, watch out, it's not copper, it's copper 2 plus, the ion is being reduced. And so when it becomes reduced, it causes the oxidation of the other species, which is the zinc there. And zinc then gets oxidized. So that's why Cu2 plus is the oxidizing agent here. So oxidation reductions reactions happened everywhere all the time, within you, outside. It's reactions that occur a lot. And for example, when you see any kind of metal being corroded, oxidized, or rusted, that's what it is. It's an oxidation reduction reaction that is happening. A lot of the times it's due to oxygen from the air. Oxygen is a very strong, hold on. Yes, so oxygen is a strong oxidizing agent because it gets reduced easily from oxygen, the gas you find in the air. It's the neutral oxygen, and it likes to gain two electrons and become the oxide ion. And because it likes to be reduced, then it's a strong oxidizing agent, and it makes all kinds of materials become oxidized. And so here, this is the example of iron. When iron is rusting, it's being oxidized by oxygen. And so the net reaction is that for iron as a solid state, as the metal elemental state, reacts with oxygen from the air to give iron 3 oxide, Fe2O3. And Fe2O3 is rust, you know, that brown rusty color. It's a powder, it's crumbly, right? It's no more iron anymore. And So iron in its neutral. So iron as a metal is in its neutral state, oxidation state 0. And when it's placed with oxygen and, humid conditions also help this, it will get oxidized into Fe3 plus. Fe3 plus and oxygen dioxide ion O negative 2 will combine and make the compound Fe2O3. So in this net reaction, we see that oxygen gains electrons. Oh, sorry. Oxygen gains electrons and become dioxide ions. And so the O2 diatomic molecule gains 4 electrons and will make 2 oxide ions, right? The molecule splits in, the two oxygens are split, and each oxygen gains 2 electrons and becomes an oxide ion. And on the iron side, iron will lose electrons and give those electrons to oxygen. And it becomes Fe3 plus and lose 3 electrons. And that's why, when you balance the reaction, there is those coefficients of 4 and 3 and 2 to balance the amount of electrons being exchanged, transferred from iron to oxygen, right? Iron loses electrons and it's oxidized. And these electrons are being gained by oxygen, and oxygen is being reduced. So that previous kind of oxidation reduction was, unwanted, if you will. We don't really like iron to rust. But we've exploited the knowledge of oxidation reduction to our advantage now, and we do a lot of things that uses oxidation reduction to our benefit. And for example, alkaline batteries are using oxidation reduction reactions to, produce electricity. And so they contain some zinc powder and manganese oxide. And so the net redox reaction is that zinc as a metal will react with the manganese 4 plus ion, and the zinc will get into zinc 2 plus, and the manganese will become, from 4 plus will become a 3 plus ion. So I want you to determine which reactant is oxidized and which is reduced. So if you remember that oxidation is loss of electrons, you want to find out which one between the zinc and the manganese 4 plus will lose electrons. And so you should come up with this answer. Zinc is oxidized because zinc starts from the neutral state, its elemental state, and becomes a zinc 2 plus with oxidation state 2 plus. And so it lost those 2 electrons. And that's why now we have 2 positive charges on zinc, because we have 2 protons that are not canceled out anymore. And those 2 electrons will be gained by manganese 4 plus. Manganese 4 plus is reduced by gaining those 2 electrons. So 2 manganese 4 plus ions will gain those 2 electrons and become 2 manganese 3 plus ions. So manganese 4 plus is more oxidized than manganese 3 plus, right? By gaining an electron, you decrease the positive charge on the ion. And so that's a reduction. There was a gain of electron there. And you can see that if you add those 2 half reactions, you come back to the net redox reaction. And the 2 electrons are canceled out because you have 2 electrons on the left side and 2 electrons on the right side. So they cancel out and you retrieve the above net redox reaction. Another useful benefit of using oxidation reduction are the pacemakers, for example. Pacemakers are used to send an electrical impulse to the heart so that it will trigger the heart to beat. And so this can be life-saving. And so the net redox reaction that happens in the modern pacemakers is that we have lithium in the metal state plus iodine. Iodine is a solid also, and they will change into lithium plus and the iodide ion, I minus. So really what happens is that the cation Li plus will combine with the anion I minus to form the ionic compound LiI, which is a lithium iodide. So can you determine which reactant is oxidized and which is reduced? So here you want to find which one lost electrons, and the one that lost electrons is lithium. You can see that lithium is oxidized because it starts as lithium in its elemental state as a metal, and it becomes the ion Li plus. And so for this, lithium had to lose electrons. And here we have 2 lithium in the net reaction. That's why we keep 2 lithium on the left, and they become 2 lithium Li plus ions, and they lost each an electron. So 2 electrons to show that they lost those electrons. And so those electrons will be grabbed by iodine. Iodine will be reduced and grab those electrons. And a bit like oxygen earlier, iodine is in its elemental state is a diatomic molecule made of 2 iodine atoms. It will be split into 2 iodine atoms, single atoms, and they will gain each an electron, and so they become the iodide ions. So that's why I2 plus 2 electrons gives 2 iodide ions, right? Because on the left it's a diatomic molecule, and on the right it's 2 atoms of iodine separate from each other, and they each have an electron in excess, and that's why we have the negative charge. So, and you can see again that those 2 half reactions, if you put them together, on the left side you have 2 Li plus I2, and on the right side you have 2 Li plus 2 I minus. The 2 electrons from the left cancel the 2 electrons from the right. So some more practice at identifying the species that is oxidized and the species that is reduced. I want to emphasize that when you are asked that question, which reactant is oxidized and which is reduced, the answer can only be a reactant. You cannot tell that a product was oxidized or reduced. The question is always asking for which reactant. There are 2 reactants, which one is reduced, and if you find which one is reduced, then you find the other one is automatically oxidized, right? So let's look at what we have here. We have 2 Na as a solid, so it's the metal sodium in its elemental state, plus chlorine, the gas. It's a diatomic molecule, and that's the way you find chlorine in nature. So it's its elemental state also. When you make them react, they become sodium plus, Na plus, and Cl minus, the sodium ion and the chloride ion. Of course, here it's specifying that because we have a cation and an anion, when they are together, they make the salt NaCl, right? Na plus and Cl minus together make NaCl, the salt. So which reactant is oxidized, which is reduced? So the one that is oxidized is the one that lost electrons. And here, if you look carefully, sodium is the one who lost an electron to become Na+. So we have Na on the left side. It becomes Na+ on the right side of the arrow. And to become Na+, it has to lose an electron, right? It's losing one electron to become Na+. So sodium is oxidized, and if sodium is oxidized, then Cl2 is reduced. Chlorine is reduced into 2 chloride ions. So we have to have the electrons added on the left side because chlorine will gain those electrons and become reduced into the chloride ions. Here again, the diatomic molecule is split into 2 atoms of chlorine, and they will each gain 1 electron and become each a chloride ion. And so to balance, you would multiply by 2 the sodium and the sodium ion and the electrons that it lost, so that you retrieve the net reaction above. So let's look at the second equation here. It's the net reaction of magnesium and oxygen. Magnesium in its elemental state as a metal, and oxygen in its elemental state as a gas. They will combine together and react to give 2 magnesium 2+ ions and 2 O-2 ions. So 2 magnesium ions and 2 oxide ions. Again here, you could also write on the right side that it's 2 MgO, because Mg2+ will combine with O-2 to make the compound MgO. So the question is, which reactant is oxidized and which reactant is reduced? And so here, the reactant that is oxidized is the magnesium metal, because we see that it becomes Mg2+ on the right side. So magnesium lost 2 electrons to become the 2+ ion. So magnesium is oxidized. And so therefore, the oxygen is reduced. Oxygen gains 4 electrons to become 2 oxide ions. Again, here, oxygen is a diatomic molecule, so it will split into 2 oxygen atoms, and each oxygen atom will gain 2 electrons. And so you will form 2 oxide ions. And so oxygen is reduced, it gained electrons. So we know that writing half reactions or oxidation reduction reactions is difficult for students of Chem 121. So what I will ask when I test your knowledge on this is I will give you a net redox reaction, and I will ask which species is oxidized and which species is reduced, or which reactant is oxidized and which reactant is reduced. I will not ask you to know how to write the half reactions. Okay, so don't worry about this too much.